Number 30. What are the mole fractions of H3PO4 and water in a solution of 14.5 grams of H3PO4 in 125 grams of water? Then we have letter A. Outline the steps necessary to answer the question, and then B. Answer the question. All right. So basically, we need to find out the mole fractions of two things, H3PO4 and water. Now, we always start with the formula of what, the question is calling for. So we want to find out the mole fraction. What is a mole fraction? Well, the formula is this. It's like any other fraction, right? Where a fraction just equals a part divided by a whole, right? If you wanted to turn a fraction into a percentage, you just times it by 100. But since we just want the fraction, we just want a part divided by a whole. Now the x here is represented as the mole fraction. So if you do see that in class, the x is the mole fraction. Now if you want to find a mole fraction, it's always of a single compound or molecule. And whatever molecule or compound you want to find, you always take that part of moles and divide it by the total moles. So in this case, we need to find out the mole fractions for both H3PO4 and water. So, moles, moles, moles. The first thing is, well, they gave us grams and grams. I can't do anything unless I convert both of these numbers into grams. Convert both of them into moles. So, for letter A, maybe I'll give a little bit of room here. For letter A, the first thing we have to do is we have to take the 14.5 grams of H3PO4 and convert it into moles of H3PO4. Then the next thing you have to do is you have to take the 125 grams of H2O and convert it into moles of H2O. So maybe I'll start part B down here. Now, if we did start off with 14.5 grams of H3PO4, and I want to convert to moles of H3PO4, how would I go from grams to moles? Well, that's going all the way back to basics, right? If you have a gram value of some substance and you want to go to the moles, all you have to do is just divide by the molar mass. So we're going straight to the periodic table. We have to find out what the molar mass is of H3PO4. Now in this case, we have 3 hydrogens, right? And on my periodic table, it just says that each hydrogen is 1.008. You can always round it to just 1. But I like to get the most exact answer as I possibly can. We have 1 phosphorus, so I'm just going to add the phosphorus amount on my periodic table, 30.97. And then we have 4 oxygens, so I have to add 4 times 16. So let's see what this molar mass equals. 3 times 1.008 plus 30.97 plus 4 times 16, right? Love Calci. We could do everything in one shot here. 3 times this. I'm just making sure that all the numbers look good. Looks good to me. And we get a molar mass of 97.994. So all I'm going to do is I'm just going to take those grams and divide it by 97.994. So 14.5 divided by that number. Just going to pull that up there. And there we go. So I'm going to say that this is roughly 0.148 moles of H3PO4. So just like we said, we had to do it for H3PO4, we got to do it for the H2O. So we have 125 grams of H2O. Let's find out the moles of H2O. Divide by the molar mass. You got 2 hydrogens, so 2 times 1.008, and then plus 1 oxygen, so that's 16. 2 times 1.008 plus 16 you get roughly 18.016. So I'm just going to take that value and divide it by 18.016. 125 divided by that number, and I get 6.938. That looks good, right? 6.938. Okay. So now we found out that we have 0.148 moles of H3PO4 and 6.938 moles of H2O. And those were the only things that were in this solution, right? They said that we had a total solution of just the H3PO4 and the water. So in order to find out the total moles, we would just add these two values up. So 0.148 plus 6.938. And that looks about right. I get 7.086 moles of the whole solution. So now all we have to do is just plug it into the formula, right? So we're going to do two separate fractions, right? We want to find the mole fraction, that's X, of the H3PO4. And then we want to find the mole fraction, which is deemed X, for H2O. Mole fraction is part over whole. So in this case, since we're looking for the mole fraction of H3PO4, I have to put down 0.148 moles on the top, divided by the total number of moles, which was 7.086. And maybe there we go. And then for water, water's moles was 6.938 divided by the total, which was 7.086. So let's find out what those mole ratios are. H3PO4 and H2O. And here we go. So let's see, 0.148 divided by that answer. Okay. And seems like, I guess, 3 sig figs. So 0.0209. And just know that mole fraction has no units. So it's just like a fraction value. So 0.0209 for the H3PO4. And then for the water, we have 6.938 divided by that total number, 7.086. And I get 0.979. And that's good for that one. Let's box this off. So we found both of the mole fractions. No units for mole fractions. And as a little check, just know that if you add up all of your components, what number do you think your mole fraction should equal to? If I take the 0.0209 roughly about and 0.979, very, 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 very close to 1. So we did it perfectly. So just know that, always if you add up all your fractions together, they should equal 1 because that's equivalent to 100%. And that answers this question. So I guess at the end, right, we had to find the moles for both, add the total moles up, and then for the last part for A, plug into the formula. But that's basically it. Okay, now we're done. I hope this helped. Let me know in the comments. Love helping you guys out. Subscribe to the channel if you want to help us out. And I hope to talk to you in later lessons. Keep studying hard. Good luck on those tests and quizzes, and I'll talk to you soon. Okay, bye-bye.